Hi everybody. Today we are presenting our new paper, a new taxonomy for automated driving, structuring applications based on the operational design domain, level of automation, and automation readiness. This paper, joint research by the Technical University of Munich, ABS Lab, and my colleagues Lina Ludwitzi and Stephen Peters from Technical University of Darmstadt, and was presented at IEEE IV 2024 in Korea. So when we look at the landscape of autonomous driving and autonomous systems today, we see many applications on level 2 vehicles, we see the first level 3 vehicles, and some intermediate levels, level 2 plus systems. But we also see already level 4 vehicles out there, and we had some promising candidates in the future who cancelled their development. By looking at these landscapes and just understanding what kind of technology is behind these vehicles, it's very difficult to understand that only by the SAE level. Especially since we have significant advancements in the last couple of years in autonomous driving development, we see the importance for a clear taxonomy and for a clear classification. But right now, we have managed many challenges with the current taxonomies. Therefore, the objective of this paper and research is to develop a new and especially a comprehensive taxonomy. Because when we look at the current frameworks, especially the SAE levels, something we already know from level 0, human driver, to level 1, only lateral longitudinal control, level 2, lateral and longitudinal control, and final level 3, where we have the possibility first off to hand off our hands and to put our eyes off. Going up to level 4, where the vehicle takes care of everything, and finally to level 5, full autonomy. These SAE levels are very good to structure our development because they give us ultimately the final accountability. Is the human or the machine accountable? But we are struggling to integrate new intermediate levels or new technology. Number 2 of the current frameworks is the so-called ODD, the operational design domain, which describes specific operation conditions under which the automated driving system is intended to function properly. Our idea in the ODD is to stepwise introduce new functionalities and increase the ODD. For example, just driving on one road, then on city roads, and then on complete urban environments. The advantage is that we have a phased approach and we have reduced security risks, but ultimately we have the disadvantagements that it's not suitable for certain kind of autonomy levels, and we have the disadvantage that it's not comparable with and over different autonomous vehicle systems. Finally, one of the current frameworks we have are the TRLs, the Technology Readiness Level introduced by NASA. It gives us a specific measurement system used to assess the maturity level of particular technology. For example, starting on level 1, basic principles observed, up to level 9, actual system proven in an operational environment. These consist of 9 rigorous states and each with own parameters that the technology must pass before becoming fully certified. So now, when we look at all these systems, we figured out that there is a clear need to combine these systems together because, number 1, we have a variability in the vehicle performances across environments. Number 2, we have inconsistent vehicle capabilities within the same SAE levels. And number 3, we lack of the coverage of the ODD and TRL in some level, and therefore we have existing gaps in the methodologies. Ultimately, what we need is especially a level of intermediate abstraction where we actually can integrate some level 2 plus, level 2 plus plus, or level 3 plus functionalities. And that was our goal to develop this new comprehensive classification system. We developed a 3-step process in which we first of all structure new operational design domains with intermediate levels. Number 2, adding the levels of autonomy. And then number 3, integrating a new ADRL, the so-called Autonomous Driving Readiness Level. The objective of this new taxonomy was to create a scalable and adaptable taxonomy and finally support science, industry, and regulation with that, because now we have a clear and comprehensive classification. Step number 1, we created a new and comprehensive ODD categories. Because when you look over the state of the art, we have a very clustered ODD categories. We combined all of them and defined what is really necessary. Number 1, the country code, where's the car driving? Number 2, road users, what kind of other road users do we have? Number 3, the road types. Is it like a highway or a highway including a driveway or departure, or is it an urban environment? Number 3, the environmental conditions, from weather to day to night to fog. Number 5, the velocity, defined in 5 different categories and additional requirements. What you see here is a very comprehensive structure of an overall ODD where everybody can integrate it in. Number 2, we are now combining our example format with the SAE levels. So what you see here on the left side is our definition of the new taxonomy. First, the SAE level is defined, in this case 4. Then we define the country code, here US. Then we define the road user, here anything. Then we define the road type, here highway plus. Then we define the road condition, here ice and snow and fog. And finally, we define the velocity, here below 60 kilometers. So therefore, we are enhancing the clarity and the comprehensibility for end users, and we integrate now the ODD with the legal framework considerations. The final step now is that we developed a new TRL, especially for autonomous driving readiness. And we call it the ADRL level, the Autonomous Driving Readiness Level, which you can see here on the right side. What we defined from basic principles, ADRL 1, where scientific results on new, for example, new neural network architecture are done, until the commercial use, where the system is in commercial use without any safety driver. So we create high relevance for the industry from ADRL 3 onwards, and we benefit of ADRL in evaluating the technology maturity. We finish here our methodology and now apply this new taxonomy to already existing autonomous driving system that we have. Number 1, the truck and highway pilot that operates day and night on ordinary highways without any driver, but is limited to southern states. Our taxonomy creates now the following definition. Number 1, it's an SAE level 4. Number 2, it only drives in the USA. Number 3, it can drive on any road type, but it is limited to highways and driving off the highway, which means highway plus. It can only drive on dry and wet environments, but not on icy environments, but it can also drive in nighttime. And 4, it can drive on velocities below 130 km/h. Additionally, no requirements, and we define that as a new ADRL 6. The demonstration in real vehicles with a driver was already done. Number 2 result is a robotaxi. What you can see here, the Waymo robotaxi in San Francisco. We know that the Waymo taxi already operates 24/7 in San Francisco and it is in commercial use. In our definition, it is an SAE level 4 vehicle in a country code USA, and it can drive on any road type, especially highway, off the highway, and in urban environments. It can drive on any road conditions in dry and wet in nighttime. Here especially, we don't know if in San Francisco it's snowing. And finally, we drive on velocities below 130 km/h. Right now, we have a special requirement. It's only in San Francisco, but we can define an ADRL 9 because the system is in commercial use without the safety drive. The final example here is now a mining truck, which operates in controlled mining environment and is in commercial use already. It is an SAE level 4 vehicle with a country code anywhere because it can operate in any country, drives on any road, but especially here on special roads with dirt, but in all road conditions, from snow to ice, from wet to dry, but drives on very low velocities below 60 km/h, and it's in an autonomous driving readiness level 9 because the system is in commercial use without a safety driver. Therefore, I come to discussion. In summary, we provided insights in our taxonomy applications. What we created here in this paper is now a new taxonomy because we identified white spots in the ODD, the SAE level, and the TRLs we have today. We provided an approved system which allows for comparison and differentiation, and it is more practicality and usability of the taxonomy for current system. In the future, we want to have more in-depth validation feedback and refine these categories even more because we want to call the industry for adoption and collaboration here. In summary, the main key takeaway. Our new taxonomy system refines and combines existing approaches and creates a new, fine granular, and especially holistic definition of the important categories for autonomous driving. Thank you very much for your time and for listening. If you want to look in the paper, here's a link, and especially a link to our lab website. If you want to reach out and collaborate together, we are happy to receive your feedback. Thank you very much for your attention.